Welcome pre-calc students, Mrs. Fallon here. We are on Unit 3, Lesson 2. So we're talking about writing equations of polynomials, and then we're going to get into some polynomial division today. And I know you've learned about like synthetic and long division, so we're going to do some overview because it's probably been a while since you've done it. And we're going to talk a little bit about how to do that in what we're going to use it for. All right, but first, let's talk about how to write an equation. So in the last lesson, we talked about like what all the parts were. We talked about double and triple and single zeros and all that kind of stuff. Today we're going to kind of use all that to kind of work backwards and write an equation. So rather than giving an equation and graph it, we're going to give you a graph and have you write the equation. So there's a few things that I want you to kind of recognize. So here's our graph, right? So the first thing I would look at is that we have a 0 at x equals 2, and it seems to be a single. Like in other words, it's just passing straight through. Here's another 0 at x equals 3. Oh, this looks like, oh, sorry, this is -2, not just regular 2. So this is x equals 3, and that also appears to be a single. So if I have two zeros, right, that generally tells you the degree of your function. So if I have 1 0 here, 1 0 here, this means I have a degree of 2. Sometimes it's a little different when we get really higher degrees, so you don't always can depend on just looking at the graph and seeing if they're doubles and triples and all that kind of stuff. But another indication is the fact that both of the arrows are pointing down. So what that means is that I have an even degree polynomial and that I know the leading coefficient is negative. And so the reason why I know it's negative is because the arrows are pointing down. So this is what you're going to do. So we're going to say this has a degree equals 2 because of the two zeros. The leading coefficient, so it's quadratic. So we're going to have the arrows are pointing down. It's even, the leading coefficient's negative. So I'm going to start off with that leading coefficient. What you're going to do is you're going to take those zeros and write them as factors. So if I need to solve something, like I need to solve this factor and have it equal -2, that means the factor that relates to x equals -2 was x plus 2. And if I need to solve something and get x equals 3, then I need the factor to equal x minus 3. So the steps here, in case you like to kind of follow along with just like specific steps, I want you to find your x-intercepts of your graph. So that's what I did first, is I labeled my x-intercepts. And then step 2 is I would say determine, and I'd say any doubles, triples, or singles. I'm just going to kind of abbreviate double, triple, single. You don't have to abbreviate if you don't want to. And then step 3, I would find the degree, and you do that by looking at the zeros, right? And the end behavior. Because the end behavior will tell you if the leading coefficient's positive or negative. So those were kind of the steps I took in order to figure out this particular problem. Let's go on to another one. So I'm going to give you example 2. So let's start with our step number 1, find our zeros. So this looks like -1, and it appears to be a single. This looks like 2, and it appears to be a double. Perfect. So my arrows are pointing in opposite directions, which means it's an odd degree polynomial. And since there are two zeros here, we count the doubles as 2, plus 1 gives me 3. I would say this is a degree of 3. If my arrows go down, then up, think about the leading coefficient for odd degrees. You always look at the right side. Since the right side is pointing up, that my leading coefficient has to be positive, because the leading coefficient tells you what happens on the right side of your graph. So I know my leading coefficient's positive, so you don't have to do anything there. The factor that gives me x minus 1 would be x plus 1. The factor that gives me x equals 2 would be x minus 2. Now, how we determine the doubles and singles, right? So I didn't talk about singles yet because all we have to do for the singles, we don't have to really do anything. But for the doubles, you need to square that factor. So if it was a triple, then obviously you would cube that factor. So that's how the factor shows up if it's a double. So it looks like x minus 2 squared, which tells you that there's going to be a double 0 at 2. All right, so the last one. So a couple things I'm noticing. So again, look at your x-intercepts. I got -2. This appears to be a triple. See how it waves or curves through there. I have x equals 1, and it's bouncing off my graph, so it appears to have a double. All right, next thing I'm going to look at the end behavior. So plus or up and then down means it's an odd degree. So if this is 2 because it's a double and this is 3 because it's a triple, I would say the degree is 5. And then you should be able to tell the leading coefficient is negative. Why? Because again, look at the right side of my graph, or even the right side of my arrows. The right side indicates the leading coefficient and vice versa. So the right side's pointing down, so my leading coefficient's negative. So negative, then write x equals 2, or x equals -2 would have to be x plus 2, and it's cubed because it's a triple. And then this one would be x minus 1, and it's squared because it's a double. All right, so that's kind of how we write equations given graphs. And so we'll do a little bit more of that in class, but just kind of wanted to give you kind of a heads up about what we're going to be doing. Let's also start talking about some polynomial division. And I know you learned this last year to various degrees, but I want to kind of revisit it because it's not it's not an especially easy topic. Once you get the hang of it, it's not so bad. But it tends to be something that, was a little confusing as we went along. So one of the things that we're going to keep asking you is like, which of these numbers are factors? And we're going to give you different scenarios, but we're not going to give you just numbers. We're going to give you expressions or, numbers and letters together. So if you're determining something as a factor, what you want to do is you want to check to see if it goes in there evenly. So if something is a factor of 738, that means it would have no remainder. So if I divide this, it would go in there evenly. So real simple, let's do old school long division. Put the 9 on the outside, 738 in the middle. 9 can't go into 7. 9 goes into 73 8 times. So if you remember what we did, is we did 9 times 8 is 72. What I always tell my students, and I know in elementary school you probably learned, oh, you subtract these. I always tell my students to add the opposite. And the reason why we do that is because it's going to get a little more complicated than this, and I want to remember not to mess up the signs. But adding the opposite or subtracting is really the same thing. So anyway, I subtract or add the opposite, I get 1. I bring down my 8. Repeat the process. 9 times what is 18? I get 2. So 9 times 2 is 18. Add the opposite, I get 0. So this means it's a factor. Why? Because the remainder is 0. That's why. So if I looked at this one over here, 11, and see if 11 goes into, a different color, if 11 goes into 738, you'll see that it's not a factor, and I'll show you. So 11 can't go into 7. 11 goes into 73 6 times. So 11 times 6 is 66. Add the opposite, and we get 7. Bring down your 8. 11 goes into 78 7 times. Add the opposite, we get 1. Now 11 can't go into 1, so we have this remainder of 1. So I want to make sure you understand how we deal with these. So we're going to talk about dealing with them in just numbers, and then I'm going to go through a couple examples with polynomials. So when we write 738 divided by 9, it equals 82. You can also write it as what two numbers multiply together to give you 738? Well, it would be 9 times 82. So those are the two numbers that would multiply together to equal 738. That's what makes it a factor. For this one, 738 over 11, so when you're dividing this, I get an answer of 67 with the remainder of 1. So don't do the R thing, because that's like way school elementary. But if you did 1 over 11, so in other words, this is a fraction of what you have left. So what this means is if I was multiplying this, it means that I'm going to do 11 times 67, but then I'm going to add an extra 1 at the end because I got that remainder kind of hanging out there. All right, let's do this, but with some polynomials. All right, so let's see here. I have x minus 3, and I have this lovely polynomial here. We are going to divide. So I want you to set up your long division. We're going to do x cubed minus 6x squared plus 11x minus 6. Just going to separate them a little bit. All right. So next, what we're going to do is we're going to go ahead and go through the process of dividing these polynomials. All right, so here's how it looks. All right, so what we do is we look at the first term and the first term. So you might have learned this in Algebra 2, but here's a good refresher. So the first letter and the first letter. So we ask ourselves, x times what gives me x cubed? So what do you multiply x by to get to x cubed? And you might answer x squared. So then what you're going to do is you're going to take this x squared and you're going to multiply it by this entire thing. So x squared times x gives me the x cubed. X squared times negative 3 is negative 3x squared. All right, this is where add the opposite comes into play. So add the opposite. So those are the opposite signs. When I do this, these always cancel out, but now I'm left with negative 6x squared, positive 3x squared is negative 3x squared, and let's bring down the next term. That's it. Now we got to repeat the process, but that's it over and over and over again. So now we go again. We say, okay, x times what gives me negative 3x squared? So what do I multiply x by to get to negative 3x squared? So I get negative 3x. So take this negative 3x and multiply by x minus 3. So negative 3x times x minus 3. I get negative 3x squared plus 9x. Because negative 3 times negative 3 is 9, and then with an x. Add the opposite. So I'm going to make this a negative. This gives me 2x. These cancel out. Bring down the next one. Repeat again. X times what gives me 2x? Well, that one's kind of easy. It's just 2. So now you're going to take 2 and you're going to multiply by x minus 3. So 2x minus 6. Add the opposite. If you notice now, everything cancels out. So when my original question says which of these expressions is a factor, we already know that this one's a factor because it has a remainder of 0. It goes in there randomly. So if I was to, normally we're going to write it like this as a fraction. So this means this big polynomial divided by x minus 3. My answer then is x squared minus 3x plus 2. I also want you to remember that this polynomial is made by multiplying this times this. These are the two factors. Just like up here where we multiply 9 times 82 to get to 738. We multiply x minus 3 times x squared minus 3x plus 2 to get to this lovely polynomial. All right, next. Let's do the other one. So I'm checking to see if this is a factor, but more importantly, we're just kind of getting the process of this division down. So x plus 2, x cubed minus 6x squared plus 11x minus 6. So that's how you set up your problem. All right, so let's go ahead and go through the process again. And let's see here. I'm going to use a different color this time. I'll use, so again, same process. X times what gives me x cubed? X squared. So remember, you take the x squared and you multiply by this whole thing. So x cubed plus 2x squared. Add the opposite. So add the opposite signs. These cancel. I get negative 8x squared. I just carried down my next term. Repeat the process until you can't go any further. So x times what gives me negative 8x squared? Well, what do I multiply x by to get to negative 8x squared? I would have to multiply by negative 8x. So I get negative 8x squared, so I'm multiplying by this whole thing, and then negative 8x plus times 2 is negative 16x. I'm going to add the opposite, and I get 27x. And now I'm going to carry down my 6, or my minus 6. I'm going to repeat the process one more time. X times what gives me 27x? 27. Notice how this is always going to go in descending order, like x squared, then x, then constant. So you're always going to have that kind of pattern. All right, 27 times x is 27x. 27 times 2 is 54. Add the opposite. I get negative 60. I have a remainder of negative 60. And how I know it's my remainder is because I can't multiply x by something to get to negative 60. So I'm done multiplying or done dividing. The only thing I can do now is call that my remainder and move on. So my remainder here, so when I divided this, what did I get? I got x squared minus 8x plus 27. And then do you remember how I wrote the remainder up here? I wrote it as a fraction. So you're going to write it as negative 60, so plus, negative 60 over x plus 2. So it's your remainder over whatever you're dividing by. So to write this out in kind of like factored form, like what did we multiply together to equal this polynomial? Well, we took x plus 2, we multiplied by this, but then we also had 60 left over, negative 60 left over. And so that's what that's going to look like. All right, that's it for now. We're going to do a lot more in class, but I figured the video will help if you need to refresh your memory on the division. I would encourage you to obviously come to class with any questions, and we will practice this more in class to give you guys a little bit more of an opportunity to hone your skills. You also have the WebAssign stuff, so if you want to check on your own tonight and just kind of see what you remember from Algebra 2 and what you don't. All right, that's it for now. Bye.